So this topic is about choosing the best alternative among the given alternatives. So let me zoom in this a little bit. Okay. How to choose a best alternative. So I'll show you a graphical technique, which is basically writing the given cash flow in terms of, let's say, present worth and plotting it. So if there are two options, let's plot the two options and see which one is better. So we'll see a graphical solution, which is helpful for you uh, when you're working as a group to come up with a solution for a problem while doing through economical analysis. So the objective is we will use spreadsheets, Microsoft Office, Excel. We will use spreadsheets or Excel to implement the formula that we come up with for every problem, and then how to plot that, and then how to view that. That's what we'll see here. For example, if we have to choose two different options, let's say rigid concrete versus flexible asphalt, how do we how do we come up with a solution? That means how do we decide which option is better? We have to do the economical analysis. So sometimes what happens is we don't know the interest rate. The interest rate varies in the, so if you see the interest rate, the problem is interest rate. This interest rate varies with the market trend. So interest rate is not fixed. It varies. So due to the varying interest rate, we have to, though the interest rate varies, we should still come up with a solution. That means if the interest rate I is between certain rates, let's say between 5% to 10%, which option is better? It's always a good idea to plot the I with the present worth or net present worth, or we can plot with net annual worth. We can do any different sort of plot. So basic idea is we want to plot I on x-axis and net present worth for, let's say, case A. So as we change I, what happens to the present worth? This is for case A, and maybe case B is like that. This is case B. So when we change the interest rate, the reason we're changing interest rate is we're not sure. So we assume that this is the interest rate range, and we plot the two ideas. So this is, let's say, option B. Let's say this is option A, right? Then we see that till this range here, and when we are plotting net present worth, let's say, so high present worth is better, right? Net present worth is the higher the better. So seems like between this range, option B, right? This is option B. This is option B. This is option B. So option B seems to be better. But for interest rate I more than this, that means between this range, option A seems to be better. And how did we come up with this? By plotting it and by observing the plots. That means we should get right plots first. So, and we think about different questions. What is the advantage of asphalt or rigid concrete? So which one, for example, if we have asphalt, we have, let's say, more miles per gallon for every vehicle that's traveling in that road. But if it's rigid concrete, let's say it is slightly less miles per gallon fuel efficiency. But rigid concrete has better safety compared to asphalt. So we take all these into account and then we come up with an answer. For that scenario, I think asphalt is better. For I think local roads, rigid concrete is better. So we come up with a solution. So so we have to perform all different sorts of cases, all different sorts of analysis. We have to look at all different alternatives, compare them, plot them, and then come up with an answer. So what we do is we will do the net present worth or equivalent uniform annual worth, or you see, we have to do either annual worth or present worth or future worth. We basically have to plot it. And we see the line of best value. Which alternative is best over certain range? We have to also look at range. For example, here in the given example, in this range I, right? So I'm waiting for this to sync. Sometimes it takes a couple of minutes to sync. Anyways, it's gonna sync. Yeah. For this range I here, like I said, option B is better. B is better. For this range, option A is better. So we have to plot. And we'll see some example problems. For example, if you look at this example, I'll solve example 8.2, but I'll discuss what's happening in example 8.1. So graphical solution. First of all, we need to get this graph. And how do we get the graph? By doing the following. So in example 8.1, what's happening is there is this engineering society that's trying to build a snack cart to raise money. So if they aim to serve 100 customers per hour, it's a case where we require lower budget, which is $10,000, $10,310. But if we have to, this is to serve 100 customers per hour. But if we have to serve 150 customers per hour, that means almost 50% increase in the customers, serving customers. We need 13,400 as initial investment. See, there is 50% increase in serving customers, but is there 50% increase in the budget when it comes to high? No, it's not even 50%. It's less than 50%. So just by looking at it, seems like this is a good idea, but we have to do economic analysis. So that's not how we can claim that this is a good idea, because we have to see the benefits. Because we sell more, then the estimated net annual income for lower capacity is 3,300 per year. This is benefit, and this is $4,000 per year. This is benefits. These are benefits. And life for both of them, N, is 5 years. So let's do economic analysis for 5 years. That means even in your project, let's say you have 2 options or 3 options, or let's say you have 4 options. You have to compare each and every option, draw a graph, because it's always easier to look at the graph and discuss from the graph. One picture is equivalent to 1,000 words. So we need to know how to get a nice plot. So here, what's happening is let's convert every number to present worth. That means there is this high option. So when in the case of high, when we have huge investment, let's do present worth for high analysis. That means present worth when we have to have high investment, high initial investment, is we convert every number to present worth. So 13,400, that's a negative number because it's something we need to invest 13,400, and we are getting 4,000 per year, and that is annual, right? That means the cash flow looks like this. So at the end of zeroth year, we had to invest 13,400, and we're getting 4,000 annually. That means for this cash flow, how do you convert every number to present? We convert 4,000, which is a positive number, 4,000, which is a positive number, to present. That means given A, how do you convert it to P? And is interest rate given? No, we will plot this for a range of interest rate. For example, in the plot there, it is plotted for 0 to 20%. So, and n equal to 5, right? So this is the present worth for analysis where we have high investment. So what about low investment? Case when we have low investment. So present worth for low, how do we write this? We are investing 10,310, and every year we're getting 3,300, and this is annual, so we have to convert it to present and equal to 5. So what is the formula for this? Only this one. Given A, how do we find P? Let me go back to the very beginning of the book. There is a set of formula. Yeah. Given A, how do we find P? I'll write formula once and I'll reuse the same formula many times. So the way we find P given A is A times 1 plus I to the power of n minus 1 over I times 1 plus I to the power of n. Yeah, that's how we convert this. That means this formula, we will pretty much write this as 4,000 times 1 plus I, we don't know I, we will leave it as I to the power of n, which is 5 minus 1 over I times 1 plus I to the power of 5. So that is the formula. Similarly, for this one, only for this term, it is 3,300 times 1 plus I to the power of 5 minus 1 over 1 I times 1 plus I to the power of 5. So the idea is, because we have the formula for present worth during high investment and present worth during low investment, we will plot it for a range of I, because we have the formula. And how do we do this? I'm going to open Excel. I'm going to open Excel and I'll pretty much implement this in Excel. So for I, range of I is going to start from close to 0%, because I is in the denominator. I'll use a pretty low value, 0.00001, which is close to zero, because if I have zero on the denominator, when we use Excel, it'll say it's error. So from here, it is 0.01, means 1%. I hope you're able to see this, right? 0.01. Let me zoom in further. Yeah. And what I'll say is this is equal to this plus 0.01. So this is 2%. 3, 4, and I'm going to drag this till 20%, right? And let me do present worth for high. So what is the formula for present worth high, which is equal to negative 13,400 plus 4,000 times it is 1 plus I. It is not I. 1 plus I is this number, right? We're assuming a number. To the power n, which is 5, minus 1. I'm going to close the parenthesis. Over I times, I'll open the parenthesis, over I times 1 plus I to the power of n. 1 plus I is this number, to the power of n, and I'll close the parenthesis. That's it. Seems like this is the present worth if the interest rate is this much. So what is the present worth as interest rate increases? Ooh, it goes to negative number as well. So present worth decreases as interest rate keeps increasing, right? And present worth comes to almost zero between 0.15 and 0.16. So that is the internal rate of return. Let's do the same for present worth when we have less investment, less initial investment, which is equal to negative 13, negative 10,310 plus 3300 times, what I'll do, I'll basically, because I'm lazy, I'll just copy the formula. I'll just copy this formula because it's almost the same. And I'll go here, I'll say this is equal to negative 10,310 plus 3300 times that, and I'll drag this. So when we drag this, let me show you, those who don't know how to use Excel, we have to take the cursor to the right hand bottom corner, and as soon as we take it there, so previously it is like a hand, it's like grabbing, but when we take this cursor to right hand bottom corner, it becomes plus. Click, drag it. So the formula applies to each and every number there. So now that we got the data, we got numbers, what we can do is we can plot it. And there are different ways to plot, but one way, I think insert. One way that I know, maybe there's a better way, you can figure it out, is to open a plot. Is there a line pi? Where is the XY plot? Maybe they're not showing enough options. Yeah, here you go. This is scatter. And I can take this smooth lines with markers. So this is the plot, but we have to choose the data. So I'll click on the plot I'll go to, I think, format. No, chart design. No. So when we click on this, I think we should have. Oh no, it is chart design. I'm sorry, we're right. It is chart design, and then we have to select data. So data, and I'm going to add a range, and the name would be, let's say, PW high, and the X values. I'll click on this, and I'll choose the X values. These are the interest rate is the X value. The Y values, I'll choose these to be the Y values. And that's for PW high. And now I'll add one more. This is PW low. The X values, I will choose these again. Oops. And the Y values, I will choose these. So we're plotting the present worth. Okay, that's what we see. Oh, wait a second, we don't know what is what. So I think it's better we have to PW high. Okay, so let's maybe right click, and we have to have a legend. It's always good that we have legend. So I typically draw plots in MATLAB or Python. So I rarely use Excel, but you have to figure out a way how to create legend here. So I think I would right click, but I don't see format plot area. I don't see anything else about legends, but you figure out a way to how to come up with the legend, because we need to identify what plot is, which one corresponds to which plot here. But because we have numbers, obviously when I bring my cursor or mouse to the blue color region, it shows it's PW high. Mm, no, it's PW high. So it obviously highlights that. When I click on blue, it highlights. So we know that blue color is PW high, but when I click on orange, it's low. But it's always good we have legend here. So I'm trying to figure out a way how to, add legend. Maybe just Google and then come up with a way how to add legend. But now that we created a plot, what we need to see is, you see this region here before. So if the interest rate, that means if we go to bank, we get a loan. If the interest rate that the bank provides is less than, let's say, I think it's 0.045 something, right? Before, that means if I is, for this plot, what we can say from by looking at this plot is is if 0 less than I less than how much? 4%, approximately 4%. For this case, PW high is better. But if interest rate is more than 4 and less than 20%, PW low is better, because higher present worth, the better, right? Higher present worth, the better. So here, after 0 point, let's say 0.05, to be on a safer note, I'm going to say 5% here. I'll say 5%, 5%. So, but if you observe one more thing here, at 18%, is it 18? Yeah, approximately at 18, exactly at 18%, and almost close to 18%. Orange color, it goes to 0. That means beyond that point, both options are useless because we get negative present worth, which is not worth it, which is not worth the investment. So that means here, what we have to say is in the analysis, less than 18%, right? Lower investment, a case where we invest, so lower budget, low initial investment is better. Okay, so this is the graphical solution. So we convert every number to present worth. We we take a range of interest rates into consideration, and we say between this range, this option is better, or in the other range, the other option is better. So we have to come up with that number. That's how we do this graphical analysis. So even in your projects, rather than you explaining in 3 or 4 paragraphs, give me a plot, give me labels, X label. So here, this is a bad plot in my perspective because I have to figure out a way to come up with X label because I have to label what is X axis, I have to label what is Y axis. Then I have to label what is the title of the plot. I have to give legend, and the numbers have to be big enough. Now I can't see the numbers, so maybe I right click, I change the font, I increase the font size to maybe 12 or 14, so I can see the numbers. Otherwise, if the numbers are minuscule, I can't. That's how we get a good plot. So font, let's maybe I'll increase to 14. Now I can see what is what. Then I have to give legend, maybe chart type, I have to figure out a way. I'm not going to waste time in the slides to figure out a way how to come up with how to create legend there. But there should certainly be a way where you can give legend describing which color is what. So I'd require you to do a similar analysis in your project where when you have two different alternatives, you see, just by looking at two different cases, we can't say which one is better. And we can't even assume that interest rates will remain the same. Or sometimes if we take certain interest, we can say, okay, this bank gives you this interest, the other bank gives you that much interest. So I think in these two options, uh, which one is better? Obviously, lower interest is better, but maybe there are other catches. Maybe the bank that gives you at a lower interest is charging you some initial fees, so to give you that lower interest rate. So incorporating that fees, you have to come up with an idea saying, is it worth it? Let's say in this case, I gave you two options. Maybe you'll have four options when you do your project. So you have 4 members in the team. Come up with 4 different cases, come up with these numbers. So this is the initial investment. I'm sorry. Right? And then you have, this is the amount we get. Let me highlight that. And we get this much benefit every year. That means this is the profit, or yeah, that's the profit. Or I think we should say in this case, this is the revenue. Maybe if there is a student worker sitting there at the cart, if you're paying him $14 an hour, and during the working, what is the working time in the student center? Maybe from morning 8 o'clock to evening 5 o'clock. And we have a cart, we are selling. So if that's an option, how much are you getting? So in 5 years or in 10 years. That's how we do. Or if you have a case where you have to compare, so example A2 is a case where we have to compare cycles with two different life span, 6 and 12. Like I said, we have done a problem in the previous classes. We have to come up with the least common multiple, right? We have to come up with the least common multiple. So in situations like that, first of all, we have to come up with a formula. So here, if you just look at this given numerical information, initial cost of machine X is $200, initial cost of machine Y is $700. The annual benefit is $95 for machine X, $120 for machine Y, and there is a salvage value at the end of 6th year, salvage value at the end of 12th year. So least common multiple is 12. And let's do net present worth. Net present worth, all the same. Net present worth analysis. So let's do net present worth for machine X. So when you do net present worth for machine X, you have initial investment. So you see, we have to be careful here. We have to get this cash flow for 12 years. So before we do this net present, we have to know the cash flow. Cash flow is we're investing 200 and we're getting an annual benefit 95 for 1, 2, 3, 4, 5, 6. At the end of 6th year, we also have a salvage value, right? So this is $95, this is $200, and this is another $50 salvage value. But that's not it. We have to give this for 12 years. That means at the end of 6th year, after we sell this, we have to again purchase this with for $200, assuming it's still $200. This is an assumption. 7, 8, 9, 10, 11, 12. This is $95, and the salvage value is $50, right? How do we get net present worth for this cash flow? What is net present worth for this X? So obviously this is 200 initially present, and we have plus $95 is annual, and we want to convert it to present because it's annual, and we don't know the interest rate, so we'll have a range in the Excel. How many years are we getting $95? We're getting $95 for 12 years in the given cash flow. What about this 50 here? That is a future value, isn't it? There is a positive 50 and negative 200, isn't it? At the end of 6th year, we have positive 50, negative 200, and that is a future value. So we want present given future for I. And what is n for that future value? N is equal to 6, right? For that future value, for this 50 and 200, correct. And what about this 50 there? That 50 is positive 50. What is present for the future for a range of I, and n is equal to 12, right? This 50 is occurring at 12th year, right? So what is the formula for this? The formula for this is negative 200 plus 95 times what is P given A? P given A, I have the formula here. 1 plus I to the power of n minus 1. This is 1 plus I to the power of n, which is 12 here, minus 1 over I times 1 plus I to the power of n. Next, 50 minus 200 is negative 150. So it is, oh, sorry. It is negative 150 times what is present when given future. I look at the front of the textbook. When given future, present is nothing but future times 1 plus I to the power of negative n, so which is negative 6. Then last term is plus 50. Same thing, 1 plus I to the power of negative 12 because it's negative n. So the formula is P is F times 1 plus I to the power of negative n. 1 plus I to the power of negative n, that's what's given in the textbook. So this is the net present worth when we buy machine X. So similarly, what is net present worth when we buy machine Y here for that cash flow is initial investment negative 700. Annually, we get 120, and we get that for 12 years. 1 plus I to the power of 12 minus 1 over I times 1 plus I to the power of 12. Salvage value at the end, so that means it's a positive, we're getting positive 150 at the end of 12th year, so 1 plus I to the power of negative 12. That's it. This is the net present worth for the two cases, machine X and machine Y, and the plot should look like this. So let's go to Excel. Where is Excel? Let's open Excel. And what I'm going to do is we'll plot it. We will implement the formula. The way we will implement the formula is I'm going to write I. Like I said, initially I'll have a really low number to represent 0%. The next number is 0.01, which is 1%. And this is equal to this plus 0.01. And now the formula is embedded there, so we can drag it down till 20%. Let's do present worth for X. Net present worth for X is equal to, our formula is negative 200. I'm going to do Y first because it's easier. So present worth for Y is equal to negative 200, sorry, negative 700 plus 120. I thought it was 150 per year. Is it 120? Yeah, it's 120. That's the annual benefit. Yeah. Plus 120 times 20 times 1 plus I to the power 1 plus I. I is this. I click that. So the variable is represented in the equation 1 plus I to the power of n. N is 12 minus 1. We have to be careful with parentheses. If the parentheses don't match, we get error. Over over I times 1 plus I to the power of 12, close the parenthesis, and we still have the formula plus 150 times 1 plus I to the power of minus 12, right? So that is the net present worth. and I'm going to drag it down close to a negative. That means higher interest rate, machine Y is not good. Let's do that for this case, present worth of X. So I'll just copy the formula for Y is equal to, what I'll do is I'll change the numbers. Initial cost is negative 200 plus 95 times 1 plus f60, 1 plus I to the power of 12 minus 1 over I times 1 plus I to the power of 12 plus, or this is a negative 150 times 1 plus I to the power of negative 6, and I will have one more, plus 50 times 1 plus I to the power negative 12, make 39. So I'll drag it down. And what I'll do is I'll plot it. Let's plot it the same way. I go to insert. I go to subscriber. In this plot, what I'll do is I'll have to select the data. Select data, and I'll add the first series, which is present worth for X, or I'll just say present worth machine X. X values are this, that, Y values are for X. Okay, that's for machine X. And then what we do is we select data. I'm going to add one more. Series 2 name is present worth for machine Y. X range is this. Y range is that. And that's it. Exactly. So how to increase the font is you right click on that. For example, if you have certain numbers, you right click on this to change the font. Yeah, so we can increase the font to maybe 14 so we can see them. So for these interest rates, if you see the orange color is Y, because I bring my cursor here, or I can select that and choose Y. Blue color is X. So orange color seems to be not a good idea for high interest rates. X seems to be a better idea. Is it the plot given in the answer? Machine Y is dotted, yeah, and machine X, see? So for interest rate beyond this range, around 1, 2, maybe around 1.2, or yeah, it says 1.3, X is better. So for this range, X is better, machine X is better, and for the range below this interest rate, choosing option Y is better. So that is how we do analysis. Okay. So that's this example 8.2. Similarly, when we have three different cases, three alternatives, I'll not solve this because I showed you how to do two different cases using two different examples. This is something that you can do. This is example 8.4 in the textbook. So there are three options that we can consider to used in a machine, maybe brass, stainless steel, titanium. Like I said, life is 4 years, 10 years, 25 years. What we can do is either we can come up with the least common multiple when we do present worth, or we can convert every number to annual worth. When we convert this to annual worth, we don't need to we don't need to uh, we don't need to come up with this assumption that at the end of fourth year we have to again purchase something made up with brass. We don't need to make all these assumptions. So if we convert every number to annual worth, and we have seen that example, one of that example in class as well, where we don't need to, even if you do that kind of assumption, you'll end up getting the same answer. So if we do annual worth, you don't need to convert 4 to 25. That means we don't need to come up with the least common multiple. So I think in this case, the least common multiple would be 25 to 50 is not a least common multiple. So we have to go, I think we have to do 100 years, which is too huge. So I think, for example, in this case, I'm waiting for the notepad to sync. Yeah, yeah. For this case, there are three options: brass, stainless steel, titanium. Now, if we convert every number to annual, because given is cost and lifespan is n, which is 4, 10, 25, and this is given as cost. So we can convert this number, given numbers, all of these given numbers, to A, because this is present, right? For example, if you take brass, it is 100,000. How do you convert this to 1, 2, 3, 4? How do you convert this to 1, 2, 3, 4? If this is 0. Given this, how do we convert left to right? Given P, we need A, and there is a formula for that. All this while we have been using the formula where A is given and we were trying to find P. In this case, we will find A given P times I times 1 plus I to the power of n over 1 plus I to the power of n minus 1. Using this, we can find annual cost. Wait a second, that means my cash flow is wrong. What I have to draw is cost, right? This is annual cost, isn't it? So when we apply this, we get certain A for each I. We apply the same formula for brass, for stainless steel. So you find out what is A for brass, which would be 100,000 times I times 1 plus I to the power of 4 over 1 plus I to the power of 4 minus 1. What is annual cost? This is what annual cost for stainless. It should be 175, 3 zeros, 1 plus, sorry, I times 1 plus I to the power of, this is 10, over 1 plus I to the power of 10 minus 1. And annual cost for titanium would be 300, 1, 2, 3, I times 1 plus I to the power 25 over 1 plus I to the power of 25 minus 1. Okay, three different cases. And when we plot, we get a plot that is shown here on the. So by looking at the plot, what do you think is the best choice? Now here we have to be careful. We are dealing with not net present worth, we are dealing with cost. When it comes to cost, you want the cost to be higher or lower? We want the costs to be lower, but net present worth to be higher, or benefits to be higher, or costs to be lower, right? So when we have the when this was when we plot this for a range of i's, seems we get a plot that is shown. Maybe let's see if I can paste it here. So I thought I could paste it. Anyways, so what we can do is, so when we see this option, when we have three different cases, which option is better? So between 0 and approximately 6%, this titanium, which is given by blue dots, seems like that is better. But between 6 and 15 or 15.3%, seems like black dots. Black dots means stainless steel. Stainless steel seems to be better. But above 15.3% and above seems like solid black color line, which corresponds to brass. Brass seems to be better. Brass seems to be better. That means for different interest rates, we have to choose different materials and consideration. So typically, if the interest rate falls around 6.3% to 15.3, which is what banks give, seems like stainless steel would be a good option because interest rates typically are between 6.3 and 15.3. So it seems like we would suggest stainless steel. So that is how we come up with analysis. So if it is cost, we want it to be lower. If it is benefit, we want it to be higher. If it is net present worth, we want it to be higher. This is equivalent uniform annual cost on y-axis. So because this is cost, we are looking at lowest option to be better. But if it is annual worth or present worth, higher the better, right? So that is the main idea of this chapter. So we can use this idea for project as well when we come up with certain numbers. So major task for you in the teams is you have to come up with these numbers, some reasonable numbers. That means what you have to do is you have to do some literature search. And some of that literature search, remember, it is not directly available. Sometimes you have to call the company, or sometimes you have to make an assumption based on something else. Make some reasonable assumption or open internet, search the internet. For example, I've seen a case where I think one of you were working on, one of the teams I think was working on setting up a production plant to make, I think, single passenger cars, because why do we need four seaters in a car when typically to work when only one person drives to work? So can we increase fuel economy? And by the way, that's a good idea. And to let you know, there is already a company, there are all multiple companies, and one company I searched was Solo. It is a that's also a car manufacturing company. They're trying to, make this single or one person capacity vehicle. It's not a bike, but it's a three wheeler. It has three wheels, one person seating capability vehicle, which gives a high miles per gallon, approximately, I think it's 50 or 60 miles per gallon. That's what we get. So that's a good idea too. So when you try to, make a device or make a machine like that, you have to come up with this initial cost, savings compared to a traditional equipment. Let's say you have a traditional car here, savings we get is almost three times. That means if this is $90 for fuel, here fuel cost will only be $30 because you get three times more mileage. Typically, if a car gives you around 20, 22 miles per gallon, if you're getting 66 miles per gallon in the machine that you fabricate, you can get almost three times. You can save three times, and the salvage value, the life, you can make some approximations and assumptions, and then do this analysis, and then say for this interest rate, I think this option seems to be good. That's one way you can do something for your project. Okay, right. That's this graphical solution method. Watch out for more lecture videos that I'll post for different other methods to perform analysis. And next, I will discuss depreciation and taxes. These are two other important things as well. After that, I think we are good to go for projects, and I'll give some more announcements regarding the quizzes or exams. Some of you are wondering when I'll be giving quiz. I'll be posting a quiz soon, but I'll make the deadline for the quiz a little longer because I know many things are on your plate now from different other courses, things going around due to coronavirus. So what I'll do is I'll give you an extended deadline so you have flexibility to work on the quizzes. But do watch all the videos. Encourage your team members also to watch all the videos because this is helpful for you to do analysis. All right. All right, then I'll see you in the next lecture.